Hi all, I'm just going to go through the solutions to the interactive test for week 8, because previously students get to this week and they don't do very well in the test and they think that they're not understanding the concepts, but sometimes it's just small mistakes in the test. So question 1, this is the factorial ANOVA follow-up analysis 2 in week 8 of the interactive room. It's not actually a test, it's a quiz. I shouldn't scare you with that word. So researchers suggested that students in Year 7 would enjoy maths than students in Years 9 and 11. They also mentioned that the relationship between year level and enjoyment of maths would be different for boys and girls. The SPSS output for a factorial analysis of variance is attached below. Given that the interaction between year level and gender is significant, select the most appropriate further analysis. So basically, if there's an interaction, you need to split the file according to the least important IV. In this example, the main IV is year level, so we're comparing enjoyment of maths of Year 7 students to Year 9 and 11 students. And then there's a secondary IV, which is gender. So gender is the least important IV, so you need to split the file into males and females and rerun the analysis. So run a one-way ANOVA for each of those groups, testing enjoyment of maths across the 3 year levels. We've got a specific hypothesis here. We're comparing Year 7 to Years 9 and 11, so we've got planned contrasts comparing Year 7 to Years 9 and 11. So let's have a look. So a single one-way analysis with year level is the independent variable specifying 2 contrasts. That's not correct because we need to do a one-way analysis for each of the groups. A single one-way analysis of variance with sex is the IV. We wouldn't need to do that because we need to, our main IV is year level, so we're wanting to look at enjoyment of maths across the different year levels separately for males and females. So 2 separate one-way ANOVAs, one for boys and one for girls, with year level as the IV, each specifying 2 contrasts, Year 7 compared to Year 9 and Year 7 compared to Year 11. That one's looking good. 2 separate one-way ANOVAs, one for boys and girls with year level as the IV, each requesting a post hoc test. We don't want a post hoc test because that's for unplanned comparisons, whereas we have specific hypotheses about which groups we want to compare in our IV. So this will be the one we click. 3 separate one-way ANOVAs, one for each level with sex as the IV. That's not correct because gender's the least important variable, so we're not doing follow-up analyses for that. We're splitting that into groups and doing follow-up analyses for year level. No further analyses would be required. We must do, when there's an interaction, you must do further analyses because the main effect is misleading. So you must look at the simple main effect of enjoyment of maths across the year levels separately for males and separately for females. There's the females, there's the males. That's the simple main effect. Okay, so move to the next question. So question 2, researchers were interested in the amount tourists spend on souvenirs. They suggested that older tourists would spend more on souvenirs than those aged 25 or younger. So we've got age group. They also hypothesised that this difference between the spending of older and younger tourists would be greater for those travelling overseas in Europe or Asia than for those travelling in Australia. So we've got a secondary IV of country or location. The relevant SPS output is given below. Given that there is no significant interaction between age group and location of travel, which of the following would be the most appropriate further analysis? So we don't need to split the data into the groups of the least important IV and do follow-up analyses because there was no significant interaction. So instead we go down here and we have a look at the main effect. So the main effect of place is significant. The main effect of age group is also significant. Age group had only 2 groups, so we don't need to do follow-up analyses because if there's only 2 groups, you obviously know which groups differ from each other. Place is an IV with 3 groups. So we've got Europe, comparing Australian travellers to Europe and Asian travellers. So we'll do follow-up analyses for the IV place, and we have a specific hypothesis of comparing, we think that the spending of older, the difference between the spending of older and younger tourists will be greater for those travelling in Europe or Asia than for those travelling in Australia. So we have, actually that's the interaction hypothesis. That this here is an interaction hypothesis. It's not a main effect hypothesis. So we don't have any specific hypotheses about the main effect of place. So the follow-up analyses would be post hoc. So a single analysis of variance with age group as the IV requesting a post hoc test. We don't need to do follow-up analyses for age group because there was only 2 groups in the IV. A single analysis of variance with location of holiday as the independent variable requesting a post hoc test would be the one we'd select because there was no specific hypothesis for the main effect of location. The hypothesis was an interaction hypothesis. We know that because it says they also hypothesised that this difference between the spending of older and younger tourists would be greater for those travelling overseas than for those travelling in Australia. So the relationship between one IV would differ for the relation. The difference on one DV across the groups of one IV will differ for levels of the other IV. That's an interaction hypothesis, not a main effect hypothesis. Okay, so let's save and submit. We'll see how we went. Scroll down and see we got the first one correct. We got the second one correct as well.